Ah, finally, some peace and quiet. Yeah. Sound. It's everywhere, but did you know squids can't hear sound, yet dolphins are able to hear sounds up to 15 miles away? So, what is sound? Sounds are vibrations in air or any other medium that carry energy as they go. Sounds are waves, longitudinal waves, meaning the particles of a medium vibrate along the direction of the wave. This causes the formation of pockets of pressure called compressions and expansions. This is why sound waves are also known as pressure waves. Sound waves are caused by rapid mechanical vibrations of elastic bodies, which pushes nearby air particles to collide to one another, creating compressions and waves. These compressions and waves enter the outer ear, pass through the ear canal, vibrates the eardrums, vibrating the auditory ossicles, which vibrates fluids in the cochlea, converting those vibrations into electrical signals for the brain, allowing us to hear. Sound waves are dependent on a medium for them to travel. Without a medium to travel through, sound won't exist. This means that qualities like the speed of sound are dependent on what medium the sound is traveling through. Sound travels faster through denser substances, such as solid metals, as these tightly packed particles make it easier to traverse than a gas like air. But the speed at which sound travels also depends on the medium's kinetic energy. The speed of sound in air at standard temperature and pressure is 343 meters per second. But by increasing or decreasing the temperature, the speed of sound will change. This is calculatable by using V equals to 331 plus 0.60 T, where T is in degrees Celsius at 1 atm. The warmer the air, the more kinetic energy, the faster sound travels. This is also true in light gases, as they have higher velocities than heavier gases. All the different speeds of sound can be summed up in this table. People describe sounds in two ways: pleasant tunes and absolute garbage. Pitch and volume. The pitch of a sound is how high or low a sound seems, which is determined by the frequency of the sound measured in hertz, which is essentially how fast sound vibrates. The higher the frequency, the higher the pitch. The lower the frequency, the lower the pitch. Humans can only hear pitches ranging from 20 Hz to 20,000 Hz. This range is known as the audible range. Sounds with frequencies over 20,000 Hz are ultrasonic, and sounds with frequencies lower than 20 Hz are infrasonic. Volume, on the other hand, is the measurement of the intensity of sound, which is the amount of energy per time across a unit area away from the energy flow, measured in watts per meter squared. An average human can hear sounds ranging from 10 to the power of negative 12 watts per meter squared to 1 watt per meter squared. However, sound intensity is measured with another unit, the decibel, which comes from the bell proposed by Alexander Graham Bell. Bells are calculatable by using logarithms. However, this would lead to a value in decimal form, which most scientists refuse to use. So instead, they use the decibel, which has the same formula as the bell, with the difference of there being a 10 preceding the log and the whole value being a whole number. In this equation, I is the intensity to be converted, whereas I0 is the reference intensity, 10 to the power of negative 12 watts per meter squared, which is the softest human ears can hear. For example, an intensity of 10 to the power of negative 10 watts per meter squared will equal 20 decibels. But do keep in mind that the intensity is increased by a factor of 10 every 10 decibels. So 30 decibels isn't just 3 times as powerful as 10 decibels, but 100. So make sure not to let the log fool you. And now for a quick recap. Sounds of longitudinal waves carrying energy caused by elastic vibrations shoving air particles to collide with one another, which are only audible when the tiny organs in our ears vibrate along. The speed of sound is dependent on the medium, its environment, determined by the medium's density and kinetic energy. Sounds come in a plethora of flavors and servings, which, if matched well with other flavors, the sound is pleasant. If not, it hurts. And yet, if there's one thing we can learn from sound, it is that despite all of the differences, each sound has a story to tell. just like people. Oh, and by the way, did you know that a sound of 1100 decibels is powerful enough to generate a black hole? Yeah, so hypothetically speaking, screaming really loud will actually make your problems go away, along with the Milky Way.